Hello, welcome back to Python Challenge for All. Okay, let's continue a little more. Last time we tried depth first search or DFS, but yeah, this was not so good. So today we will further implement a little wiser approach, which is generically called best first search. So what is best first search? Let's look into the let's say Wikipedia page. Best first search is a class of search algorithms which explores a graph by expanding the most promising node. This is very interesting. Most promising node chosen according to a specified rule. Okay, it's a class of algorithm. So we'll try um, one example today to do that. So it says append path candidates to OpenL just as BFS, best first, breadth first search, but then try first the best candidate, seemingly the best candidate in OpenL. Okay, so let's implement that. So today we'll try first uniform search, uniform cost search. So this is a good way to go on to further better approach it. So improve the code for better performance in uniform search first. Okay, so um, let's make some improvements. Lesson 83. So let's see. Last time we tried this. So maybe we'll save as EL uh, 083 uniform search, cost search. Okay, let's try this. So to do that, first thing we need to do is, actually we have represented state using a list of panels. But then for efficiency, using tuple is better. So let's try that. For do that, maybe we can try, for example, we use tuple instead of list. So here, for example, in solver, the solver gets a list of panels. Then to give it to, say, try, we'll use instead of list, okay, instead of list, yeah. So we use tuple of board instead of list, okay? Then what else do we need to change? For example, we need to change the goal state to, instead of list, this is same, tuple of the past one. So yeah, let's see what it looks like, but later, yeah. And then in the, okay, in the solver function, basically it's the same thing. Stat is pop one thing. If the pop start is goal state, then it's fine. But otherwise, yeah, maybe instead of returning the path, we'll return a list of paths. So list S for S in path. So this will be fine enough. Okay. So instead of returning, yeah, path will have list of tuples. So now we change each tuple into list. Okay. And this is fine. And here too, next stat. Yeah, in next stat, maybe we will change next moves. Yeah. In next moves, this will get tuple. So maybe here, this will get tuple here. So here we'll change list of stat, and then do the same thing. And then instead of adding new stat, we make tuple of new stat. Okay, this is okay. What else? Maybe we'll change. Oh, is this all? I guess so. So we have changed next stats. I mean next moves. Okay. Return from solver, we have changed it. Return from solver, we have changed it. And then goal stat. So I think this works. Let's try this to work properly. Okay. So S. Give up. Oh, really? N. S. Okay, fine. Oh, this is not good. But it seems it's working. So fine. So we'll do today's work. So next, we will sort OpenL using the past path length. So let's implement sort OpenL and put it just before popping up. So here in solver, so here's pop up. Okay, so before popping up, we'll change the order OpenL equal sort OpenL and given L. So this function, sort open well, L, will do the sorting. So let's implement that. Here, def sort open L. Oh, open L. Given open L. So new L, let's make a new list. And then, maybe no, we don't need this. So here, sort open L using the past path length. So to do that, here, uniform, let's see what uniform search is. So uniform search is another name for Dijkstra's algorithm. Okay, so in Dijkstra's algorithm, okay, here, Dijkstra's algorithm, it says in many fields, particularly in artificial intelligence, Dijkstra's algorithm is a uniform cost search. And what is uniform cost search? So uniform cost search is used to pick up according to the distance from the start state. Okay, so to calculate that, we'll sort using the length of the past path. Okay, to do that, we need to make a list, new list. Let's see, what else? Maybe we can just, we can just, for path in new L, or open L, we can do it, of course, using list comprehension, but we'll just, so here, let's calculate gval as length of path, okay? And then we'll, instead of just path, we make a list of gval and path and append it to new val. And after calculating everything, new L, sort, and then using sort using the first element, okay, just like this. So we'll sort using the Gvel instead of, yeah, here, okay? So it's like key equals lambda x x0. So, well, this will sort the new elements according to the ascending order of Gval, okay? And then we'll return everything. So like path for, yeah, now we want to remove the first element in new L. Okay, so this will return just like the list of paths in OpenL, but this case in ascending order of Gval, which is a path length from the start. And actually, this is all we need to do this time. And then we'll pop up the first one, just like BSD. Okay, here, this is very important. Pop up the first one, which has the shortest path, the path which has the shortest distance from the state. Let's try this and see how it looks like. Okay, S. Okay, good. So good news is that now we are back to the original state where everything can be done with an optimal path. Okay, S. Okay, 13 steps. Very good. So actually, in fact, this is just the same as breadth first search in case of these sliding puzzles, because the cost for all paths are uniformly 1. Okay? So this is actually uniform cost search in 8 puzzle is same as breadth first search. But anyway, we made a very good improvement in the code so that we can try a wiser, even wiser algorithm by changing this sort function. And we'll do that next time. Okay, that's all for today. I hope you are with me now and come back next time. Bye bye.